Alright, sorry Ben, we didn't record this problem for you, but we're taking one more day of review. We'll have our test tomorrow.
You get to have me instead, alright.
Here we go, number 2.
Alright, so I'll go ahead and write out the initial problem. I know you guys can see it, but I'm going to do it anyway just for reference. So I don't have to stare at my stuff all the time, even though I probably will. Can we use the thinner ones?
Okay, click on the lines over there.
These?
No, go on over. Yeah, touch that. It says it's on that.
It's the thickest setting?
But that's not the thinness. Let me try something.
Because this thing's coming out.
Okay, mine's writing thinner. Try writing now. That's annoying.
Wait, what does this do? What's that? What does calligraphy pen look like?
Fatter. Alright, let's just go with the pen.
I don't need to erase it. Alright, anyway, you can correct me if I'm wrong, but if you were to already plug that in, it would have came out to just infinity over infinity, which is one of our starting ones, so you know you can already go straight down to L'Hopital's. Got it. One is big, bud. Now what I need to actually, where's my pen? There it is. So what I did to start, we're doing the derivative up top. Wait. Yeah, no. Am I stupid here? I'm thinking antiderivative probably already, aren't I?
You're doing derivative, so derivative of x squared would be 2x
Yeah.
over derivative of e to the 2x.
So just e to the 2x is in chain.
And then you have to do chain rule, so times
And then
derivative of the exponent, so derivative of 2x is 2.
which then it's still going to come out if you were to plug the infinity in there, you still have infinity over infinity once again. You want to do the towels. Remember, Ben, to actually write your stuff out, please and thanks. Anyway, you derivative of your top gets you a 2. The bottom is still what? E to the 2x again?
Would now times, so it's already multiplied with the 2, and then derivative of 2x is 2, so now it's times 4.
Which, I don't know, if you can even, would you still be able to do something divided by infinity?
Yeah,
It's not 0.
right, so it's a number over infinity, which goes to...
Okay, so that's 2 over infinity, which just goes to infinity. Or is it, no, it wouldn't be negative infinity, would it?
It would be 0. Remember we talked about, like, if we have 2 pizzas and we invite more and more people in.
My bad. Work leading up to is fine, I just didn't remember.
Alright. Thank you. Next one.
Okay, so first up, the problem is can't really get anything from there to do L'Hopital's yet. So what I did was I took natural log of x divided by x cubed.
So you still have the limit in front of that, right? Okay.
Yeah. And I use L'Hopital's. It's 1 over x. Then the denominator is 3x squared. Now if you plug that in that is 1 over infinity over infinity. So that ends up being 0 over infinity, which is just 0, right?
Yeah, you could do it like that.
Alright, now I can write it down.
Yeah, because you can read that.
No, I meant because I could see now.
Oh.
Corbin, you know we help.
You were standing in front of
You were standing right in front of it, that's why I moved.
Good point. Oh.
All right.
I'm short.
One last L'Hopital's. Remember, to use L'Hopital's, it has to be 0 over 0 or infinity over infinity. So that's why we had to rewrite some of these. We ready?
I already know. Trying to decipher its writings.
It's a little sloppy.
No, a little bit. Oh, okay.
So if you plug in your 0, you get 1 to the infinity power. And our approach to that is we add a natural log.
Approach, okay.
So you get natural log of 3x plus 1 2 times 1 over x, which that would become over x. And then if you plug in your 0 in that one, you get 0 over 0. And then
Go back up a second, would you?
Mhm.
Okay, so you just put your log and moved it. Okay, I'm with you.
Okay. So then you can start L'Hopital's. And so then you get 0. Ah! Sorry. 1 over 3x plus 1. Over the derivative of x, which is 1.
Okay, and then on the top, the derivative of a natural log is 1 over the argument, but you'd have to do chain rule. So
Oh.
times derivative of the inside, which is
3.
3.
So then you get. I actually don't know. What do I get? Second.
You get 3.
Okay. So. Yeah. If you plug in 0, you get 1 times 3. Ta-da! Oh, no, since you added a natural log, it's
E
e
cubed.
to 3.
All right. All right, so that's the end of our L'Hopital's practice. Next thing up is optimization. So on your handout, I tried to put some little hints, things to remember. So remember, you have to use the information given to write an equation in terms of one variable only. And then anytime I ask you to find a maximum or minimum, it's the derivative equal to 0.
Okay, so I put my x equals pupil. And then my y equals the price.
Which is how it has to be on these, because it's going to ask you what price should be charged. So we're trying to maximize revenue. So revenue has to be a y value, which means the price has to be a y value.
And then I did 2, are they called points?
Mm-hmm.
Okay. That's 1,000. And then got this.
All right. Are you guys okay with those points? It says when the price is 15, they sell out, so that's 1,000 tickets. If they raise the ticket price by $1, 50 less are sold. So now we're finding the slope. You could, well, click that.
-20.
Is that what it is?
-20. Go ahead and have that over. Give yourself a nice third spot. Guys, make your basic addition. Not basic one.
Well, now we can get price.
So that's our price function. And then how do we get revenue if we have a price?
Times it by X.
Right. The revenue equation is price times quantity. That's the amount of money we bring in. And then that's what we want to maximize. So now we do the derivative. Alright, set that equal to 0.
I don't know if I did that right.
Oh, I didn't get that actually.
You would subtract your 35 over, and then multiply by negative 25.
Yeah, I did that right.
So 875. Is that our final answer? No, the question was what price? 875 is the X, so that's the number of tickets. So plug it in to the price function, which is why it is so beneficial if you are labeling things so you know where your price function is. Alright, so we need to be charging $17.50 a ticket. Is that okay? So moving on then. Question number 6. Before we actually do the question, I put that you have to know all of your summation formulas, and I put 4 of them there that we need to know, so let's fill that in. So the sum from 1 to n of I. What's that formula? Next one. From 1 to n of I squared. From 1 to n of I cubed. And from 1 to n of a constant. Constant times n. All right. So problem number 6. Using these formulas, I have to add that up.
like I'm doing this right.
What's the n?
8.
So we could go ahead and use that. So yes, this is a formula, but if our n is 8, so we're going to do 8 times 9
Oh, okay.
times 17 over 6 minus, this would just be 4 times n, which is 8. And then we just grab a calculator.
I got 376.
Yep. All right. Number 7.
Oh, thank you so much. I don't need to write that now.
I was trying to be nice.
Just so kind. Alright, since 12 is our value, we can just go ahead and start. So 12 squared, actually, hold on. There's 10, so let's make sure it's on that one. Alright. So our formula is n squared, parentheses n plus 1 squared divided by 4, so 12 squared is 144. And then 12 plus 1 is 13 squared is 169. Divide that by 4. And you get 5 times the original I value, which is 8. Oops, that's my bad. 12. That's what I need. 12, 13 divided by 2. So then we go ahead and input everything here. Let's do that real quick. This is a nice, fun, big number.
Sorry about that, guys.
Okay. Go ahead and check me on that one, guys, just in case.
That's what I got.
Okay. Just making sure I'm not goofing around here. Relatively short and sweet on it, but the only time is really just putting it into your calculator, or, smart enough to.
All right. Is this helping, guys? Kind of refreshing all the different things you need to know and how to calculate them. So, but you get the nice one. 2 parts. Know how to find left, right, and midpoint sums. So on this one, I only asked you to do the right and the midpoint, but I could ask for any of the 3 or all 3. So,
And then I got done with the left hand one because I read left, right, midpoint up top. So
we're doing it on the interval 3 to 6, and the n is 5. All right.
Do you want to be writing that or something?
Huh?
Do you want to be able to read or something?
Just trying to be nice.
So the first thing I did is I got the change in x, which was the 6 minus 3 divided by 5 for n. So it's 3/5. And after that, to be honest, I did the wrong one because I started with left hand, so I'll have to. But I did the. First of all, it's 3/5 times everything, and then it's 2 minus 18, 3 times 18 over 5 squared plus 2 minus 3 times 21 over 5 2 minus 3 times 24 over 5 squared plus 2 minus 3 times 27 over 5 squared plus 2 minus 3 times 6 squared. Again, I don't have the answer calculated.
Do you guys know why he started with the 18 over 5? Mm-hmm. If you think we're starting at 3, okay, so if I start at 3, we're going to go up by 3/5. So you could do decimal or fraction. This is 18 over 5. So 3, that's what you would use if I asked for the left. 18 over 5 is where you start if we ask for the right.
And I don't know if I plugged it in wrong or what, but I got negative 331.648. Guys will not want to check that because I feel like that's
What'd you
wrong.
guys get?
I'm actually still writing, so it's gonna be a hot second. Cause I did it wrong at first.
Let me check real quick. I got a different answer, but I could have plugged it in wrong.
I mean, it looks like most of these are going to be negative because it's, yeah, like, I mean, each of the insides are negative. Oh, yeah.
I got negative 207.84. That's okay. It happens. That's why I double checked my answer. I didn't trust myself either. All right. Then midpoint. Let's just set it up. We don't even have, let's not even take the time to make sure we plug it in correctly. What do you use for your first one?
Kind of write out like how I get it. I mean, so usually I take like 15 over 18 over 5 and 18 over 5. Yeah, look at that. You know, there's not an obvious one right now, so I double it and do 30 over 10 and 36 over 10. So it's 33 over 10.
Good.
From number 2.
I like it.
And then
You can also use
plug those in.
decimals if you're struggling. That might be easier too. We're going up by 3/5, which is 0.6. So if you think this is 3, this would be 3.6. So the middle is 3.3 or 33 over 10. All right.
And
So
before you
just,
go, plug all that in.
do you guys know how? Let's just write out. So let's not actually calculate it, but let's write it out to make sure everybody knows how. So you do the 3/5 times.
3/5 times the 2 minus 3 times, and we start with 33, or 33 over 10, or 3.3 squared plus 2 minus 3, and then you just go by the 3/5, which here would be 6/10 to make it easier, so 39 over 10 squared plus 2 minus 3
Doing okay with this? All right, number 9. And just so you know, if you have problem 12 or 13, I'm probably going to change those because the numbers are really, really ugly as I'm working ahead on these. Okay, if you read the little blurb above, I'm not asking you just to do the normal integral on this. I want you to do the limit as n goes to infinity of the sum from 1 to n of the f of x sub I change in x to calculate this one.
So you start off by finding your change in x, which is 6 minus 0 over n, or 6 over n, and then our x sub I is our starting plus our change in x times I, or 6 over n I. Then you plug everything in. The limit as n approaches infinity, 3 minus 2 times 6 over n I times 6 over n. Then, if you factor that out, you get 3 minus 12 over n I times 6 over n. What's 6 times 12?
72.
Thank you. And square. You can. Oh, I didn't write my summation. My bad, y'all.
Do you guys see what he dropped? The summation before, after the limit, but before all that. So now he's going to do his summation.
Yeah. You get the idea. So then you do 18 over n minus 12 times n squared I, which is n.
That's a 72, not a 12.
Oops. Thank you.
You're welcome.
So then you can simplify. That would
Be 36, right? Because that's a 2 on the bottom. Okay.
then you get the limit n approaches infinity of 18, since the n's cancel, minus 36 n over n plus 36 over n. Those will cancel. And then if you plug in your infinity, you get 18 minus 0. Nope. My bad. 18 minus 36 plus 0. Is that negative 18?
Yes, it is. All right. So if I ask you to do it this way, you have to do it this way in order to get the credit. Is that okay? All right. So then we get into all the antiderivatives. So we are going to attempt to get through as many of these as possible. When you see that integral symbol, all it means is antiderivative. So the first one,
You don't have to write anything in front of it, do you? So 3 says, is it just sine?
because you're asking yourself, what has a derivative of cosine? So that would be a plain sine.
The inside stays.
Would be 1 over 4, right? Because if you think about the chain rule, you'd have to multiply by 4, but we want to cancel that.
That's the one I was
And what else do we need on the end? Plus c. Yeah, the dx goes with the integral symbol, and when it goes away, if we don't have numbers to plug in, we put the plus c. That's it. All right, number 11.
Can you just do the antiderivative?
Not yet. We can't do a product or a quotient in reverse.
Oh yeah. So you have to do. Is that even? That's the same.
Mm-hmm.
Okay. Now you do the antiderivative.
And that's still a product.
Then actually you don't do that yet. So you FOIL this.
Mm-hmm.
And so you take that times that.
So, yeah, put your intervals. Okay. So now, when you do the antiderivative, what do you do with all those exponents? Add 1.
And so that means you have to put the reciprocal.
Mm-hmm.
So it would be 4/15.
Negative 4/15. Yep.
Negative 4/15. And so then you do that to all of them.
Mm-hmm. And the only thing I would say is you could reduce 4/20 to 1/5. But you got it. All right. Number 12. I'm going to change the limit on this, or a thing on this one to make it work out a little bit nicer. But actually, we might just set it up and not actually calculate everything because we are about to run out of time. I'm going to change that to a square on the bottom. Sorry.
Instead of an 8th power.
Yeah, instead of an 8th. 8 is kind of ugly.
Okay, let's start. You can just make it.
Good. Write it as a -2 power. So now we can do the antiderivative.
Should I multiply that inverse and then do antiderivative? Or
I would just let the 4 stay.
okay. So what's that? Well, no, hold on. It's not -1/2. Yep, never mind.
It's okay.
Just a quick sec. Wouldn't it just be a negative on the outside?
Mm-hmm. Okay, and So just to kind of clarify, this 4 is multiplied. Think of this as like a -1.
1.
It's a -1 power. You also have to think, what's the derivative of the inside? So what would we need to cancel a 7? 1/7. So if we put these together, 4 times -1 times 1/7 would be a -4/7.
So then it doesn't matter. No, it's not distributing.
And then we had limits,
Yeah.
right?
Fine.
From,
3 and -1.
so you have the -4/7. A -1 power is like 1/. So if you plug in the 3, 21 minus 5 is 16. Minus, plug in a -1, -12. And I'm just going to tell you for the sake of time, if you get that, you get -112. All right. We only have about 5 minutes left. Out of the next 3, do you know how to do number 13?
No. I mean, probably.
I'm going to change it from -1 to 1.
If I think about it, I can do it, but.
Okay, a cube root is like what power? Right, you have to get rid of any quotients or products before you do your antiderivative. So to bring that up, it's a -1/3. So if you multiply that through, you get 3x, so 4 plus -1/3 is 11/3. Minus 2x, 1 plus -1/3 is 2/3. Plus 4x to the -1/3. And then can you work it from here?
Yeah.
Okay, so then work your problem from there. Do your antiderivative. Number 14. Just trying to make sure we hit all of these before the end of the hour. If you have an absolute value, what do we have to do? Okay, to find that splitting point, you set the inside equal to 0. So you get 5x equals -10, so x is -2. So we're going to integrate from -4 to -2. And from -2 to +5. Now, if you plug in something between -4 and -2, like if you put in a -3, is this positive or negative inside here? Negative. And the absolute value makes it, so it does the opposite of that. Or you could write that as -5x minus 10. If you put in something from 2 to 5, that's positive, so the absolute value does nothing. So then it's just 5x plus 10. And then could you guys work it from here? Yeah, just do your antiderivatives and each of them and add them together. 15, last one. Okay, so dy dx is the derivative, and it told you the derivative was equal to this. And that y of -2 equals 6. What am I asking you to do?
Do the C.
Find the c. So the antiderivative, before we can do the antiderivative, we would have to multiply this out. So square it and distribute the 2x. So that would be a 32x minus 48x squared plus 18x cubed. So then your antiderivative of 32x minus antiderivative of 48x squared. So it becomes x cubed, so 1/3 times 48 is 16. This becomes an x to the 4th, so 18 divided by 4, or 9/2, plus c. And then how do you find the c? Yep. So you plug in a -2 for all of your x's, and I'm going to run out of time probably. and set the whole thing equal to 6. And then once you have your c, you've got your final equation.